Okay, hello everyone. I changed my mind last minute of what we were going to do today because I was looking at the handful of people that turned in the practice quiz, and a majority of you guys left the last four problems blank. Now, the majority of class didn't turn in it at all. So most of y'all need to get your life together. I know you're major senioritis. We have literally 1 month. Suck it up, Buttercup. I'm walking you through it. You got this. I believe in you. But I did want to go over some of the practice quiz solutions today. And then I'll open up the quiz tomorrow. I was originally going to give you Thursday, Friday to do the quiz. Now I'm going to give you Friday through Monday to finalize and turn in that quiz. But I did want to go over some of these practice solutions because they're important and they are on the quiz. And I do realize that two of the problems from section 7.2 I did not get a chance to go over live, and I also was too sick at the beginning when I had COVID, y'all, to even have the energy to make a video like I do now. So I apologize about that. I did ask you guys one day to go through the slides and click through and see, but I do understand that that can be a challenge. So I know it's not ideal, which is why we're going to go over some practice quiz solutions right now, the last four problems here for you. So let's move on. Okay. So I'm just doing the last four. So I'm going to do 5, 6, 7, and 8. The first four you are all capable of doing. And for the people that did turn it in, y'all knew how to do the first four. The last four, though, a little tricky. There's one of them that is riddled with typos and makes no sense. So I'm going to make sense of it for y'all. But I wanted to go through these, excuse me, with you guys. So we're starting with problem 5. Now, if you did not do this practice, I highly suggest you get out a piece of paper and you do these 4 with us and then collaborate with your peers to do the first 4 and turn those in. So if you already turned in your assignment, you will have an opportunity to re-upload it and earn back any points that you might have missed for not doing the last 4. If you didn't turn it in at all, again, you're going to have another opportunity to turn it in and get some points for some of it, especially considering I'm walking you through half of the problems. That's half of the points. And if you just did the problems wrong the first time and you still want to re-upload it, go ahead. I'll be honest with y'all. I just checked if you tried and I gave you points for the problem. So excuse me. I really goodness gracious, y'all. Sorry, I can't breathe too deep or I get into a coughing fit. But yeah, so you will have plenty of opportunities to make back points. Yes, it will be marked late. No, I don't take points off for it. But I did want to go over these 4 points. So, problem 5. You decide to hire movers to help you move into your new place. Use the 2 situations below to help you write and solve a system of equations to determine the moving fee and the mileage charge. So here's the first situation. You hire 4 helpers to unload and load your moving truck, and you travel 25 miles on the highway for a total cost of $525. Situation B says you get the help of 6 people to help you load and unload this truck. But you end up driving 38 miles because you took side streets and so added more mileage to it. And then your total cost for that was $800. So if we look at what this question is asking, it's kind of asking 2 separate things. Okay? I'm going to highlight it. So first of all, it wants us to write a system of equations. So that's the first thing we're going to do. And then it wants us to solve the system of equations. Okay, so those are the 2 things we need to do. We need to write a system of equations and solve a system of equations. And one of our systems is going to be on situation A, right? So this is one part of the system of equations where it says like you hire 4 helpers to load and unload the moving truck, and you travel 25 miles, and it costs you $525. Okay, so we're kind of going to group similar things together. Then we look at the other situation. We got situation B, right, which says we're going to hire 6 helpers to load and unload. Oops. We're going to travel 38 miles, and it's going to be a total cost of $800. Okay, so we can see some parallels here. For situation A, we have helpers, we have miles, and we have cost, right? So if we think about this, we have loading. Hold on a second. We have loading and unloading, right? And let's just give that a variable. Let's let loading and unloading be X. The next thing we have is mileage. Let's let that be Y. And then they both have the different total costs. So we'll just let costs be costs. Okay? So if we were going to write a system, the first thing says to write a system. So if we were going to write a system of equations, we would say that since we've hired 4 helpers to load and unload, and then we also had to, in addition, go 25 miles, and that cost us $525, this would be our first equation. And in the same event, we would go through situation B, and we see that now in this instance, we need 6 helpers to load and unload. Additionally, they got to drive the moving truck, and they have to drive it 38 miles, and our total cost ended up being $800. So this right here, this is your system of equations. Okay, so that in its entirety, this is writing a system of equations. So we've written a system of equations. Now, when it says to solve a system of equations, we need to take these 2 equations that we came up based with our situation and solve for variables x and y. Now, you can solve this system a multitude of ways. You can solve it with elimination. You could solve it through substitution. And I think those are the 2 methods that we can use. There might be one other, but I'm going to tell you that the solution to this system does not make sense. I'm going to show you how to find it, but I'm telling you, if you're trying to make sense of the problem, it does not make sense. You get a negative number for one and a positive number for the other, but it doesn't make sense to have either negative mileage or negative loading or unloading. That doesn't make sense. So the reason that this doesn't make sense is because I made this problem up a year or 2 ago, based on the type of problems that we had seen in section 7.1. This problem by itself actually is similar to exercise 6 from 7.1 that we went over last week, or the week before. I don't even know. I don't know what we did what. It was the week before. So this is how you write a system, but the solving strategies still work, but the answer itself does not make sense. Now, on the quiz, the answers make more sense. I double checked that and made sure. So let's go over how we would solve. Okay, so if we're going to solve, oh no, I don't want to use that. if we were going to solve, there's two ways. You could either do elimination, which means you are going to get one of these equations to be completely eliminated, like the x's, you add them, the two equations together and the x's disappear, or the y's, or you could use substitution. Honestly, elimination is easier to do than substitution for this particular example, just because they don't divide very nicely. Like when you're going to, when you substitute, you solve for one variable and then plug it back into the other, and they just don't divide real nicely. So I'm going to show you how to do the process of elimination, okay? So if I'm solving, I'm also going to erase this because I need space, okay? I'm also going to get rid of this. So when I am solving this system, my goal is to get things to cancel out. And looking here, I have 4, 6, 25, and 38. 4 and 6 have a common multiple of 12. So if I, excuse me, sir. If I multiply both of these equations by some values, I can get the x's to cancel. So like, for example, 3 times 4, that's 12. So I'm going to multiply the entire equation by 3. So 3 times 4x, I'm going to do it up here actually. That's 12x, right? 3 times 25, that's going to give me 75. 25, 20. Yeah, that's going to give me 75y. And then 3 times 525 is going to give me 1575. Okay, so I did that. Now, the second equation, I also want it to give me 12x, but I need it to be off by a sign. So I'm going to multiply this equation by negative 2, because negative 2 times 6 is negative 12x, and I need them to be opposite signs. See how 12 plus negative 12 is going to give me 0 12s? It's going to get, 0x. That's what I want. Now, negative 2 times 38 is going to give me negative 76y, and negative 2 times 800 is going to give me negative 1600. So, when you're eliminating, you add these two equations together. And what happens is a variable is eliminated. It goes away. And that is exactly what we wanted to happen. Okay? That's exactly what we wanted to happen. That was the whole purpose of choosing elimination. Now, 75 take away 76, that gives you minus 1, minus y. And 1575 take away negative 1600, 1575 take away 1600. That's going to leave you with with negative 25. Hello, stylus, negative 25. I don't know what's the deal here. Negative 25. There we go. Okay. So, and if you divide both sides by negative 1, you get y equals 25. And remember, y represented not the loaders, but the number of miles. That's what y represented. Once you use elimination, you can just plug this value back into any of your original equations to find out what x is. So, for example, I'm going to plug it probably into the first equation, makes the most sense because it's smaller numbers. So if I plugged y equals 25 into here, I would get 4x plus 25 times 25, that's 625, is equal to 525. If I literally just plugged in y right there, you would get 4x equals, take away 625 from each side, that's negative 100. Divide by 4, you get x equals negative 25. Here's what I said where this isn't going to make any sense. Remember, x represented loading and unloading. How could you have negative 25 loading and unloading? Like I said, doesn't make sense. But it will make more sense on the quiz. But that is how you could do the process of elimination. You also could do substitution. It is just less fun because when you're solving for like X or Y, just 4 and 25 and 525, those aren't divisible nicely. Like they're not all divisible by 5 or something. So it just makes it a little bit uglier. So I'm not even going to talk about that. We did substitution when we did these problems in class, so hopefully that jogs your memory. Hopefully you wrote it down. But again, this problem didn't make total sense. Technically, the solution is x is equal to negative 25 and y is equal to positive 25. And just really quick, I want to show you guys like that this system actually does work. like this is the actual answer. It just doesn't make sense in context of the problem. So I'm going to pull up Desmos. Okay, so I already have it. So here's the two equations. 4x plus 25y is 525. 6x plus 38y equals 800. And then I plotted the point that we just solved for. X is negative 25, y is positive 25. So at first glance, you're like, what the heck? There's only one line. But if I get rid of this, you'll see that the red line is directly below it. So although they're not parallel, like they don't have the same slope, if I like really zoom in, it's going to take me a minute to really see. They're really close to each other. But, okay, maybe I have to go. See over here, we're starting to see where the lines are not touching. So they're not parallel. They're not the exact same line. They just are really, really, really close. As a matter of fact, I checked the slope of one of them, and it's 0.16. And then I checked the slope of the other one, it's 0.157. So they're incredibly close to each other. And as we get closer and closer and closer to x is equal to negative 25, you can start to see that the lines themselves are getting closer and closer and closer to each other. I just really have to zoom in. And then as we get over here to negative 25, that's where they actually intersect. So this is the true solution, but again, in context of our problem, it doesn't make sense to have either of these values be negative. So that will not be the case on the quiz. But I did want to bring it up because I know some people are going to try and make sense of it and be like, that doesn't make sense. But I wanted to bring that up. Okay. If y'all hear me munching on ice, it helps my throat. Okay. Question number 6 is littered with typos. I don't know what happened last year or the year before. Whenever I made this review, but like I didn't finish my train of thought. So I'm gonna edit it. I'm gonna tell you what it's supposed to be. But we'll just start off with the problem as is and start solving the many things that this question is asking. On the quiz, they would be broken down and categorized, so not all of this stuff would be asked in one single question. But it says a rectangular room is 18 feet by 25 feet, and the ceiling is 10 feet high. Okay, so you gotta imagine a 3-dimensional room. And so a lot of these problems, you need to draw a picture of what is happening in order to make sense of it. Without drawing a picture, you're going to be like, I don't know what to do. You got to draw a picture, okay? So it says, first to find the length and width of the smaller wall, and then find the area. Those two things go hand in hand. They're very easy. Then it says, find the length and width of the bigger wall and find the area of that bigger wall. Again, same thing, just the opposite walls. Nice and easy. Then it asks, what is the square footage of the entire room? Okay, so Those types of questions would definitely be asked together. So let's draw a picture and answer those questions before we get into the painting and before we get into the air conditioner, okay? So for this problem, again, we're going to need to draw a picture. And when we draw a picture, we're going to need to draw it like three-dimensional, like a room would actually look. So, you'd have like, here's a room, right? We have a rectangular figure, but it's 3D. Now, I don't know why it gets a little wiggly when I use my stylus on my computer, but pretend those are straight lines, okay? So if I drew three-dimensional object, like here, I'm actually like pretty good at this. This is kind of crazy. There's my three-dimensional thing. And so remember that it says that the room is 18 feet by 25 feet, and I don't know, yeah, the ceiling is 10 feet high. Okay, so if we're thinking about this and we're just looking at the picture, like the longer wall is obviously this one. Wait. Psych. Okay. The longer wall, that's awkward. The the longer wall, but yeah, no. Excuse me. The longer wall is obviously this side, which is 25. I said it right. I used the wrong color. And the shorter wall is obviously this one, just based on like my picture. Okay, how I drew it. So there was this line here. Again, so this side would be 25 feet. This side over here would be 18 feet. And if we're thinking about a ceiling, the ceiling would be from the floor to the top, right? Like using our common sense, floor to the top. So that is going to be 10 feet tall. Okay, so that's all it is with our drawing. And you could draw like 10, that's still 10. This one over here, that's 10. This guy back here, that's 10, right? This wall over here is going to be the same. I'm just going to highlight them so you can kind of see the color range. Like this is 18. I mean, heck, this is 18. This is 18 too. This is going to be 25 feet back here. That means this is 25. That means this is 25, right? Just so you can get a visual. And you're like, probably now you're thinking, oh my gosh, this makes so much sense. I don't know why it wasn't before. You got to get the picture, okay? Pictures make a world of difference, all right? So, the first question says, find the length and width of the small wall. So if you're looking at the small wall, you're like, yeah, it's obviously this wall right here. That's the smaller one. And so if it's just asking you to find the length times the width, that's not first things. Find the length and the width. The length of that, well, it doesn't even matter which one's which, right? 18 by 10. That's what that first question is asking. Because the green side is 18 and the orange side is 10. Then it says to find the area of the smaller wall, and that literally means just like multiply these two together, which gives you 180 square feet. So, surprise, we did both of these things right here. Then it asks you to do the same, but to find the length and width of the bigger wall, which now, looking at it, you're probably thinking, okay, that's this gigantic wall right here. So if it asks you to find length times width of the bigger wall, it doesn't even matter which one comes first again. 25 by 10. And the area of that is, you're actually just going to multiply them together. That's 250 square feet when it asks you to find the area of the big wall. That question. Okay. Now, this last question says, what is the square footage of the entire room? Okay, so when you're finding square footage, it's really just length times width again, but of the big wall times the small wall, like not necessarily taking account the ceiling. So that means we're finding the area of like this rectangle. It's usually like, think of like if you were going to install some flooring. And so obviously that's going to be 25 feet times 18 feet. And if we were going to find like the square footage, that's the actual area. That's literally all it is. And 25 times 18 is 450 feet squared. So you can definitely expect a question like this on the quiz, where it's going to describe a rectangular room. It's going to give you the dimensions. You'll need to find the length of the length and width of the smaller wall and area of the smaller wall, length and width of the bigger, area of a bigger, total square footage of the room. That is one type of question. Okay. Now, I don't know what happened in my brain, but I went hog wild with the rest of this. So let's talk about the painting situation, okay? The painting. I'm gonna erase all of this stuff, so I'm gonna need some space here, okay? Actually, I think I'm gonna need that information, but that's okay. All right, so when we talk about painting, the painting situation, there will be a painting question because it's not that hard. I just worded it really funky on this part for you. Okay, so when I talk about you want to repaint a room for whatever reason, okay, with one coat of paint on every wall. When I say that you're gonna repaint it with one coat of paint, that does not include the ceiling. Okay. That just means you're painting all four walls. And then I will give you how much a gallon of paint costs. Okay. Now, the missing part of this problem is I also need to tell you, like, how much square footage the 1 gallon of paint will cover. Because there's no way for you to know that. So, for this type of problem, you will be given, oh no, I don't want to draw in yellow. You will also need to be given how much square footage 1 gallon covers. So I looked it up. It's on average, it's about 350 feet or square feet. Okay, so 1 gallon covers on average 350 square feet. So that would be given to you in the problem. So then the question is, if you want to repaint it, how much is it going to cost? That's the question. How much is it going to cost? Okay, so from the previous area that I erased, we found that the small wall, right? The small wall was 180 square feet because that was the 18 by 10. Okay. And we also found that the big wall, that was the 18 by 25, had, no, I'm sorry, 25 by 10 had 250 square feet. Okay. The entire room, that was 450. That's just like the carpet or a ceiling or something like that. So both of these, you need to paint the small walls and the big walls. And there's 4 walls in a rectangular room, right? Like if I were to count it out, this is where they would be. Here's one small wall. Here's another small wall. And then here's a big wall. And then there's the big wall behind it. So we need to really just multiply both of these by 2 because we have 2 of each of those types of walls. So 180 times 2, that's going to give us 360. And then 250 times 2, that's going to give us 500. So if I add those two square footage up, 360 plus 500, that means I have 860 square feet that we need to paint. And then, again, remember, I'm going to have to tell you how much square feet does a gallon cover. So since I told you that it covers 350 right here, divide this by 350 square feet, right? To get like how many gallons are you going to need? And then we get the fact that you're going to need 1.42 gallons of paint. So whenever you do these problems, you're going to round up to the nearest whole gallon. So I'm not going to round up to 1.5. I'm not going to try and get pints and like all quarts of paint and all different kind of stuff. Just round up to the nearest gallon. So that means we're going to need to buy 2 gallons of paint. And if I need to buy 2 gallons of paint and it's $44.50 each, that means you're going to do $44.50 times your 2 gallons of paint that you need to buy. And so that's going to cost you $89. Okay? $89. Very straightforward. It's just the wording on this problem totally sucks. And I apologize. I also apologize for how messy this is kind of coming out. My stylus is acting up a wee bit. So that's how we do that. Now, for whatever reason, this problem started to have a third entirely different type of problem attached to it too, which is the BTUs for calculating air conditioning levels. So if you look to buy like a portable air conditioner that goes in your windowsill, they're calculated through British thermal units, and that's just basically how well it's going to be able to cool down the space based on the measurements and a bunch of other factors. So this was actually in the Google Slides you guys are supposed to look over, but again, I completely understand that it is difficult to look over PowerPoint without a teacher there. So the third and separate type of question is going to be the British thermal unit, and I'm going to walk you through that one right now. So I'm going to erase all this other stuff, and we're just going to focus in on this last piece here, okay? I'm going to leave my picture. But we are going to talk about the BTUs, okay? Now, this has a formula. It's actually like a very straightforward formula. I really actually like this types of problems. But this is the one I'm going to focus on, okay? So, and it also doesn't make sense. It's missing information too. So, this part. How large of an air conditioner round to the nearest 1,000 BTUs? So, this is a third and separate type of problem, okay? So, the formula that you need to solve this excuse me, is BTUs, British thermal units, is equal to while divided by 60. And while stands for stuff. So like, for example, W stands for width, the width of the room. H stands for height of the room. I stands for insulation, which is a factor where I would have to tell you if it's well insulated, if it's poor insulated, and I'd have to give you a value associated with that. L stands for length, and E stands for exposure. So depending on which direction your room is facing, north, south, east, west, that has an exposure to sunshine and that has an effect on how well your air conditioner is going to work exactly. So if your room is facing north, it's really weird. If your room is facing north, that has a value of 16. If your room is facing east, the exposure value is 17. If your room is facing south, your exposure value is 18. And if your room is facing west, your exposure value is 20. Okay? Don't ask me how they came up with this, but but these are just standard things. Okay, so based on this problem, we're literally just going to fill in W, H, I, L, and E, multiply all of those numbers together, and divide by 60. That's really all it is. Now, this doesn't tell you. It tells you that it's on the south side and that your exposure is 18. So notice that like matches with this value right here for E. But what it doesn't tell you is if this room is well insulated or poor insulated. So I'm just going to go out on a limb here and just make it up and say that this room is well insulated. Because, modern. And so I have to tell you, if it's well insulated, your I value is going to equal 10. Okay? So if we were going to solve for our BTU then, BTU is going to equal the width of the room. So it doesn't really matter which one, but let's just say like 25 is usually length, 18 is the width, okay? The height of the room, the height of the ceiling, that has a length of 10 feet. The insulation level, I just told you it's going to be 10. The length of the room, that's 25. And E, the exposure, was given to us as 18. You literally multiply all these numbers and divide by 60. So 18 times 10 times 10 times 25 times 18. It's literally just a straight up calculator problem. This is 810,000 divided by 60. And when you do that, you get 13,500 BTUs. So that's the type of problem. That's the type of things I'd be looking for. Now, when you go, like in real life, when you go to buy a air conditioner, you need to make sure on the box that it says that many BTUs or more so that you get excellent air conditioning in that room. Usually I have people look it up and see what it looks like, but we're kind of running out of time this semester. So that's the third type of problem. It's really not that hard. I looked at the quiz. It's clearly discussed. It's clearly labeled. You know if it's well or if it's not. I tell you, depending on which way it's facing, what that value is, but you will need to write down or remember that BTU is while divided by 60, where W is width, H is height, I is insulation level, which will be given to you. L is the length of the room. E is the exposure value, which will be described and given to you in the problem, and then you divide it all by 60. It's literally just a calculator problem. So I hope that cleared that up. So number 6 was a hot mess. It was technically 3 separate types of problems, but they're all kind of related. So I think that's what I was going for, but honestly, I don't know what Passmore was thinking a couple years ago or last year. All I know is I was probably walling out. That was almost an entire year of teaching online and then having to do hybrid. So we're just going to move on to the next problem then, which I don't think is such a hot mess. Okay, so you're going to build a hexagon-shaped flower bed in your backyard because you're so hipster, okay? You want the side lengths to be 2 feet by 8 inches. And you measure the apothem to be 5.5 feet in length. First question is, what's the perimeter of a flower bed? Second question says you're planning to use cedar planks and you find them at a certain price at Lowe's. How much are you going to spend on lumber? That's a stupid question, and you'll see why when we solve it. And then what's the area of the flower bed? So with this, you're going to need to draw a picture, okay? And I promise I'm not going to judge how you draw a hexagon. Hexagon has 6 sides, so that's 1, 2, 3, 4, 5, 6, okay? We're regular hexagon, which means that technically it doesn't look like it, but all these sides are congruent, okay? And it even says that you want the side lengths to be 2 feet in length and then a width of 8 inches. This This information right here, irrelevant, stupid. But so each of these is 2 feet. So I can label it. I should even write 2 feet, right? And we know that the apothem is 5.5 feet. Now, apothem was a definition, starts from the center of your polygon and it goes to the midpoint. Okay, it doesn't go over here. That's not an apothem. That's like a radius or something. An apothem goes from the center to the middle side length, and we can label that too. We said that guy's going to be 5.5 feet. Okay, that's an apothem. So the first question, and a super duper easy question, is what is the perimeter of the flower bed? The perimeter means add up all the sides. So 2, 4, 6, 8, 10, 12, right? The perimeter is 2 times 6, since all the side lengths are 2 and there's 6 sides, or you could literally just count it up. So the perimeter is 12 feet. 12 feet. So you need at least 12 feet of wood to go around and make this flower bed. Okay. Now, the second part that I said was kind of stupid was you're going to plan to use planks. Okay. You want to use cedar, whatever. It's better for growing as your flower bed. And you find at Lowe's or whatever, you find 1 inch by 8 inch by 12-foot planks, and they cost this amount. Okay. So again, we're going to draw a picture. If you were to find a plank of wood, obviously that's a 3-dimensional thing. That's a 3-dimensional piece of wood. So that means you've got like, here's this piece, and then you're going to have this long, like, plank. Okay. So if we're drawing this is obviously not to scale. Maybe this side is 1 inch. This side is 8 inches, and then the long side is where you have 12 feet of the plank wood, okay? And this one, for one piece just like that costs you $28.73, okay? Now, the reason why I said this is a silly question is because it says, how much will you spend on lumber for the flower bed? Well, if you only need 12 feet, and this side length is 12 feet, like technically I could just cut this into 6 equal parts, right? And this 8 inches matches this width of 8 inches. Like it was a silly question. It's kind of just trying to throw you off with excess information, but the amount that it would cost is just 1 plank of wood, $28.73. Now, let's say that the amount of wood you needed was, let's just say, what if the perimeter was 18 feet? Like, instead it was 3. You wanted them to be 3 feet apart or something like that. Then you would need to buy at least 2 planks of wood, so $28.73 times 2, and that would be how much wood you would need. So, like I said, that was a silly question. Then the last question, which you will definitely need to know, and there's a special formula for this. What is the area of the flower bed? So, an area of a polygon, and this was in the notes too. An area of the polygon is 1/2 times the apothem times the perimeter. So you need to write down this formula, but remember this little a means apothem. Apothem. This P means perimeter. And you're going to multiply it by 1/2 or divide by 2, whatever floats your boat. So this means the area of this regular polygon is 1/2. The apothem is 5.5. And the perimeter we already found to be 12. So when you do 5.5 times 12 and divide that by 2, let me grab my trusty steed here. 5.5 times 12, that's 66. And divide that by 2, that means the area is 33 square feet. So the area of a polygon is 33 square feet. Again, you need the formula written in light green. You need 1/2 times A times P. You need to know A is apothem, P is perimeter. Okay? I looked at the quiz. I will ask you an area question. I will ask you. It's such a straightforward question. I will ask you something about that. I'll probably ask you also about the perimeter. I don't think I'm going to ask you how much materials you need. Okay? So be prepared. And the last question, okay? You meet with a landscape designer and you want to build a freeform koi pond in your backyard. You have 10-foot by 15-foot space to put in this freeform. You're going to use the Monte Carlo method, which again was in the notes that you're supposed to look at, where 3,000 points are randomly plotted. And of those 3,000 points, 1,200 of them land within the dimensions of the pond. So those are key pieces of information that will help you find the area of the pond. Okay? So again, we're going to draw a picture. With all of these, it just helps to draw a picture, all right? So we are meeting with our landscape designer, right? And so we have a 10-foot by 15-foot space. So here is maybe 10 feet by our 15 feet space. And we know that we want to put a free-form koi pond. So free-form just means like random, okay? So we have a random spaced koi pond in there, okay? Now, this is actually a super straightforward problem. We just have a couple key pieces of information. We have 3,000 points that are going to go in the rectangle. So there's going to be 3,000 points that are randomly scattered all throughout this 10 by 15 foot area, okay? Of those 3,000 points, we know that 1,200 land in the pond. Okay, that's very important because when we look back at the notes at what the Monte Carlo method is, which is crazy cool, we're going to need to know how many points are inside the area, how many points are inside the rectangle, and we're going to set up a proportion with the shape and the rectangle. So the Monte Carlo method says this, all right? So this is the key to the problem. You're going to need to write this down, okay? So basically, no, I don't want to use the highlighter. The Monte Carlo method says that the number, it's a proportion, the number of points inside the area divided by the total number of points, usually in the rectangle, is going to be equal to the total area. This is of like our irregular shape, of the shape, like our freeform shape, divided by the total area of the rectangle. Okay, so you can think of the numerators as being the irregular shape. So like the number of points inside our irregular shape is equal to the total area of the shape. And then the total number of points of our rectangular area is the total area of the rectangle. Like they're both on the denominator. So what I'm saying here is like just notice that like this is the shape, the irregular shape that we have, like whatever it happens to be. And then the denominator is always in terms of like the rectangle that we have here. Okay. So you're going to need what I wrote down in red. And since we have information, we can set this problem up easy peasy lemon squeezy. So again, notice that it said 1,200 points land in the pond, all right? So that means 1,200. It goes on the numerator. That's in our irregular shape. And there was a total of 3,000 points that went inside the rectangular area. And now this is going to be equal to the area of our pond, which we don't know. That's what we're trying to find out, divided by the area of the rectangle. So 10 times 15 is going to be the area of the rectangle. That's 150. To solve this problem, you just cross multiply. Like 1,200 times 150, that's 180,000. And that's going to equal 3,000 and the area times the area. To finish solving this, you divide both sides by 3,000. And then you get that 60 is equal to the area. Actually, 60, when we're talking about area, it's square feet. So that's actually how you do this problem. So the area of our koi pond, our free-form koi pond, according to the Monte Carlo method, is 60 square feet out of the 150, which is pretty cool. Anyway, so those were those problems. I hope you feel better about preparing for the quiz. Again, turn in these problems. If you didn't do them, resubmit them, turn them in, make up your points. If you didn't do it at all, get to it because you will definitely have a quiz on Friday. All right, y'all. I'm pretty sure that's all of the questions. Thanks.